Well, hello and welcome to the sixth of our series of webinars about Vulcan 10 functionality, which is Vulcan Evolution Interaction for Open Pitch Scheduling. Before we get started, I'll just give you a few quick housekeeping things. First thing is you will receive a recording of this webinar if you have signed up to listen to it, and also it'll be made publicly available within the Maptek user base for anyone who wants to grab access to it. And you'll see that on the Workbench start page or other ways of getting access. The second thing is there is a question panel there in your go-to webinar screen. You'll see down the bottom there it says questions. Feel free to type any questions you think of while you think of them, and at the end we'll stop and try to go through as many of them as we possibly can. If we can't fit them all into the session, we'll certainly try and we'll get back to you afterwards with the best answer we can give you. Putting my Workbench product manager hat on, I'm very excited about this talk. I've had the opportunity to hear it a couple of times now, and I think it's a great example of the way Maptek's heading, where we're not only concentrating on improving the functionality and ease of use of our of things to do within our products, but also between our products. And you're starting to see the fruits of our labour of integrating our different products, and that's only going to get better and better using the Maptek Workbench as we go forwards. So Eduardo, I'll introduce, is one of our senior mining engineers from our Perth office, and he's had a lot of experience in both Maptek Chile as well as Maptek Perth. And the talk today is really going to be looking at some of the new tools and workflows that streamline the connection between Vulcan and Evolution Scheduler to prepare your blocks for open pitch scheduling. He'll give you a quick rundown on Evolution and then really hone in on how the new functionality in Vulcan 10 provides you an intuitive interface to focus on usability and validated results.
Thanks, Peter, and hello to everyone. Maptek Evolution is our scheduling solution, which utilizes advanced mathematical algorithms to help a My Planner in design and scheduling for a given project. Through the use of the latest technology in software design, Maptek Evolution enables the user to use a single block model dataset to generate multiple schedules. The level of detail goes from strategic to life of mine, scheduling through more detailed and medium-term scheduling. Maptek Evolution can also schedule holistically across multiple model, bit, and multiple sites, allowing dynamic creation of production scheduling alongside automatic whole row allocation and waste landform optimization. We will have a particular webinar which will cover in more detail our scheduling solution in next month. Please feel free to join us in order to get a better understanding in the Maptek Evolution capability. Today, our focus will be in how we can make sure that the information related to tonnages and grades can be easily assigned from the mine design in Vulcan to a block model variable available to be consumed by Maptek Evolution. As I mentioned before, the base information for Maptek Evolution is the block model, which contains the mine design, which are the stages flagged in each block. It's important to mention that the block model can be either a Vulcan block model file or a CSV file, and the mine design in general are solid or surfaces. Other interesting aspect that we would like to share with you is the capability to use the Maptek Workbench released this year to connect the different applications in an easy way. The key point will be how we can assign the stages in a particular block model variable, keeping the consistency between tonnages and grade, given that the base information are different. We got the solid versus the blocks. It's important to mention that this can be done in previous Vulcan version. However, there are a series of the steps involved: flagging, calculate fraction, block model scripting, etc., etc. And sometimes you might require a strict skill capability in order to generate an automatic process, which will allow to use every time that the mine design changes. Of course, this involves a big effort, not just in the script itself, but also require multiple checkpoints in order to avoid mistakes. So what we did in 10 was to develop an option that allows achieve this task in a very nice workflow that will be capable of easy to use, auditable, and repeatable. The new option is called Maptek Evolution Model. You can find this one under the block menu. You can use either surfaces or different kind of solid. I will show you in a few minutes in more detail the difference between inclusive and non-inclusive naming convention. The main goal will be to flag the mine design in a particular block model variable, but also we will take the opportunity to calculate some useful information, which will speed up the process when we will be in evolution. One important aspect is the ability to check the result in order to move with confidence to generate scheduling later on. Let's go to Vulkan now to show you how the option works. So here we go. So let's start to talk about the different information that we can use. So let me start with the solid. So this is the typical solid that our customers are using in order for the mine design. So you got the pushpad 1. The solid for the pushpad 2 is totally independent of the pushpad 1, and the 3 is independent of the 1 and 2. So we call it this one in our interface inclusive solid. But we also have some customers that they use to have the accumulation solid. What I mean then is, let's put this one maybe in a section view. Right. So what I mean then is the pushpad 1 contains all the blocks for the pushpad 1, obviously, but the pushpad 2 is accumulated. So that what I mean then, we got blocks for pushpad 1 and 2, and the pushpad 3 include 1 and 2. So obviously we need to play a little bit with the priority here in order to get the right flag. And lastly, we got some customers that they use surfaces. So let's put them here. And obviously, if we can use this one as well, no problem. But we need to provide the topography in order to generate the flagging, the correct flagging. During this webinar, I will be using the non-inclusive solid, which is most popular with our customer. All right, so let's go to the option, which is under block, manipulation, Maptek evolution model. The option works with a specification file, so in that regard, it's quite easy to say all the steps and use it later on. We got the block model here, so we can pass through the option, and I will explain in detail a couple of options. One of the interesting things with the interface is you don't need to worry about to add the variable before to the block model, because the interface recognizes that you don't have the variable there, and add the variable and then do the calculation for you. Then you need to decide what is the triangulation type that you want to use. As I mentioned before, we will be using non-inclusive solid. Now, in order to get this solid through the interface, you got a couple of options here. You can click one by one if you want, but we got another button here which allows to bring all the information in one single shot. Maybe the order of the sequence here is not the sequence that you are looking at the moment, but we also provide another option which allows to sort this information quite easily. Now, the only thing that we need to provide here is the block value for this particular variable name. And another interesting thing here is the interface is smart enough in order to recognize the different kind of data. So for instance, if we are going to use inclusive solid, then I need to take care of the priority. And if we are using surfaces, then I need to take care of the projection as well. Let's go back to the non-inclusive. Here, you got the ability to save the temporary block model variable, which allows to record the proportion for each pushpad in each block. This is quite useful for reconciliation purposes, so I highly recommend that you don't delete this one. We are actually flagging by majority volume. You can still apply a few more things instead of the percentage, but we recommend obviously the majority volume in order to get a more close result against the solid. So that's it in terms of the flagging. The next step will be trying to calculate the total tons and the ore tons. For that, we are actually incorporating the break-even cutoff rate, which essentially allows to define what will be ore, what will be waste. But if you got a more complex situation when maybe the ore depends on another material type, etc., you can obviously do that one in evolution later on. You can also take the opportunity to apply some or add some extra variable during the process, which will be very handy when we are in evolution. So at this stage, I am recording the processing cost, recovery, rehab, and a basic mining cost. I will come by later on to explain more things. Another interesting thing is the reporting area, because allows the user, after the process is finished, check the number and see if everything match. So let's run now and see the result. So now we got the result by here. Automatically the report is populated, and also the variables has been added to the block model. So let's take a look to the blocks in order to explain in more detail how the option works. So let's load the stage that we are working at the moment, and let's put the data types here. Let's go into one particular section. All right, so as you can see, in this case, for instance, I got a stage 2, and essentially because the volume is 4,400 against the volume in pushback 1, which is 3,500. This is quite simple because it's just two pushback sharing the same block. But sometimes you got another block which share more pushback share the same block. So in this case, we got the three different pushbacks are present in the same block, and because the volume in the pushback 2 is bigger, then we assign the stage 2. Then another important aspect here is the ability to incorporate all the blocks that touch the triangulation. In that regard, we can keep the consistency with the number. And as you can see here, we got just 38 cubic meters actually recording that one, and that allowed to generation at the end. So now you got a clear idea how the option works. So let's go back here. What we want to do now, we are ready to go to export information of the day and see if we can match the result. So in order to make a fair comparison, what I want to do now is actually calculate the reserve. That will be at the moment of truth, basically. So we select here the solids, and we will generate the report now. Another interesting thing here, so we got the report which is coming from advanced research using the solid. And we generate some reporting. So this one was generated automatically by the option. So as you can see in the CSV editor, which is part of the workbench in Vulcan 10, you can see that we are quite close. So 87.2 million ton total against the 87.2 million. So actually it's quite spot on in terms of the global value, but also the idea behind this option was trying to keep the minimum difference between the stages as well. And as you can see, we can achieve for pushback 1 31.8 against 31.8. They're also a good match in terms of the grade. So we are quite happy here. Everything match. What we're going to do now is how we can actually move this information to evolution. So for that, we can use the workbench, which allows to connect with different Maptek applications. For this particular webinar, I will try to get access to Maptek Evolution. It's just a single click, and you will be ready to go. So this is the interface for Maptek Evolution. Let's open one specification file. Here we go. So the first step will be how we can actually bring the Vulcan block model here. So these are green icon that we can read the Vulcan block model, or we can read the CSV if we want. So let's pick the block model that we already flagged. He recognized all the fields. You can actually assign some transformation on the fly as well, because for the scheduling purposes, we maybe don't need all the blocks. So what we're doing actually is filter out all the blocks which contain a stage greater than 0. And we also assigning the stage will be the key for this new block model. So basically what the option is doing at the moment is reading the Vulcan block model directly, applying the filter, and then every block that passed the filter obviously become a block in the evolution block model. So let's bring the block model that we created. Here we go. So we got all the blocks. Obviously, we got different options. We can apply coloring if we want. But certainly this looks quite right, let's go back to Vulkan and display the blocks as well. I want to share with you, which is called block viewing display regular model. This option is quite nice because allows the user to display multiple variables at the same time, multiple block model if you want. More importantly, allow to load a huge amount of blocks in one shot. Another interesting thing is through the workbench and the property editor, you can get access to the block model, and depending on the variable that you are using for displaying purposes, you can actually filter out dynamically. So here we can see the blocks in Vulkan, and share the screen with the two applications. Let's close that one for now, just for space. And as you can see, it looks pretty much the same. But how we can make sure that are the same? So the only way that we can do that one is through the reporting. So we got here our reporting using advanced research against the solid. Here we got the reporting from the blocks in Vulkan. So what we're going to do in Evolution is a quick pivot report. I got a existing layout, so just click here and we got the number. So as you can see, again, the number are pretty close. The grand total are the same, and obviously a small difference between the stages. Of course, because here we are using the block, this one is exactly this number here. So now we can move with confidence in order to generate some schedule if we want. Another interesting thing here is how we can actually interact between the different applications. For instance, if I really want to put some surfaces here to give some better aspect to the data, you can actually do drag and drop and bring the topography if you want. So any of the elements you can put on top of here and take a look. But again, because we will have another webinar with Evolution, I just want to show a few things. Evolution, when you run the scheduling, everything is predefined, so you don't need to worry about reporting, nice graph. You can investigate the sequence quite nicely, etc., etc. Again, hopefully you can join us in the next webinar. So let's go back to Vulkan now to show you a few more things with this new option. So if we come back to the Maptek evolution model option, I would like to explain a little bit more in this section. So the first exercise, I just really put a single value in this particular variable. Now you can have the ability to calculate an incremental mining cost if you want to. Again, maybe this you can write a script to do this one, but the idea is doing simple in one simple spot. So essentially, you provide a series of data, reference bench elevation, bench height, reference mining cost, and how much extra mining cost would you want to add for each bench above and below the reference, the bench reference. Now, you can, if the calculation is more complex than this one, maybe you got your own script, so you can also select one script, and the system will run that one on the fly. And if you let's say that you have a special calculation for each bench. So I got another CSV here. Let's open up. For each bench, you got different calculation, and every bench has different number. So in that case, you can copy and paste here. Basically, you will ready to go. So essentially, you can calculate different mining costs in one shot. We are calculating incremental, use through the script, and user defined. So let's hit OK here. Yep, that's fine. So what we're gonna do now is just remove this one from the screen, and let's load the block model again, just to show the incremental cost. I don't need that one. There we go. Let's bring this section again. Okay. So as you can see, we got the reference bench elevation. this one, and then we're actually adding 15 cents going up and going down. So the same color means that we are actually doing the same thing. We also did a user-defining calculation. So let's change the variable here to, we call it user-defining mining cost. And in this case, we keep the reference here, but then obviously we are adding more here than less here. So it's totally different. So as you can see, it's quite simple. The interface is quite nice, and you can do multiple things in one shot. Now, let me close this thing here. Another interesting thing is if someone wants to put this process in a macro, you can actually write this one. You can use the integrated shell application that we got. And there is an external program that you can use. The name is VTOEO. And essentially what you need to do is just the specification name that you want to run. And the system will run the process for you in a C shell environment. So that's it in terms of the Vulkan. Let's go back to the presentation. During the development phase, we were lucky to have multiple customers that shared with us some data set to generate different tests of this new option. Because we have different elements, we got the surface, the inclusive, non-inclusive, etc. We need to make sure that using any of those elements, the result will be in order the order that we want. As you can see through the use of solid, the results are really good, not just in the grand total, I mentioned this one, but also doing a comparison stage by stage. There is less precision using surface, but we are talking about less than 1.5%. So in summary, we were trying to achieve an option which allowed to generate an streamline process to add the staging information in a block by block. It allowed to execute useful calculation on the fly, and hence reducing the number of scripts and steps. Generate a repeatable process, simple and easy to use, which retain consistency between the solid and the blocks. And obviously the most important thing, the user experience will be highly enhanced. So that's for now. I hope you enjoyed this webinar. Thanks for your time.
Thanks, Eduardo. It's great to see how that development has improved, I guess, the ease of use and the introduction of a workflow to make what would have been a series of related scripts and options all into a simple process which then goes and talks directly to our scheduler. We have had a few questions come in, so if you've got a little bit of time, I'll quiz you. First one says, look, the client has a block model. It isn't a regular one. If they have, say, a sub-blocked or a heart model, will the options still work with those kinds of block models?
Yeah, absolutely. That's the beauty about this new development that we're incorporating in 10. So you can use any kind of Vulkan block model, obviously, and the option will be performing quite nicely.
Thanks for that. The second one here is, if the client doesn't have evolution yet, can they still use the option?
Yep, that's right. This new option is part of the My Modeler OpenCAD. So if you are under maintenance, you will get access straight away for this option, so you can start to use it. And if you are interested in evolution, just give a call, and we are more than happy to help you out with that.
The next question, the user noticed that in your demo you had 3 stages. They have more like sort of 20 or 30 different flagged stages or requirements to flag. Can it handle that sort of number of stages?
Yeah, there is no limit in the interface at the moment. During the testing process, we had the opportunity to play with around 30 different stages. The option worked very well. Just is a matter of time, basically, but there is no problem at all with the new option.
Okay, and the final one we have here, if you have any others, get them in quick, but in your demonstration I think you showed a quick BCF block calculation script. What are there other types of scripting formats that can be used with this option?
Yeah, we can incorporate the BCS, which is the block model calculation, but we also can use the C#. So if you got a C# doing different routine, you can actually select that file from the interface and use it during the process as well.
Okay, so that's all the questions we've had so far. If you do think of other ones, please send them in to the contact details, and quickly on the screen there you can see if you need to get hold of Vulcan 10 to take advantage of some of this, go to the users area and there'll be a login and password you can take advantage of. So certainly send any questions you think of post-webinar. As I mentioned at the start, it will be recorded, has been recorded, and will be made available to you. And there are a bunch of other webinars still upcoming on the Vulcan 10 functionality, and also, as Eduardo mentioned, one specifically for the evolution scheduler. So please keep an eye out for that if that is interesting to you. Now, I'd just like to finally, I guess, thank Eduardo on behalf of all the listeners today for providing an overview of that new Vulcan evolution interaction and the new option within Vulcan 10. And just once more from personally, thank you, Eduardo, and see you at the next webinar.
Thank you.